Hello, I'm Yehan Liu. Welcome to my Lab1 report, which is about charged tape. Okay, so first the introduction part. The purpose of the lab is to determine the approximate charge on a piece of charged tape by analyzing the balance between gravitational and electric forces. And the fundamental physics principle used is the Coulomb's law, which describes the electric force between charged objects and the principle of balancing forces to maintain equilibrium. And here are some equations evolved. The first one is Coulomb's law, which is used to calculate the electrical force between two charged tapes. And the gravitational force is used to determine the weight of the floating tape. And the equations of electric field is used to model the field created by a charged tape. There are two models involved in the lab. The first one is the experimental model. We observe the interaction between charged tapes to measure forces and determine the amount of charge required for one tape to float above the other. And the second computational model, we use a simulation to model the forces between the tapes, assuming each tape is a single point charge to calculate the required charge for floating equilibrium. And here's a preview of the result. So the amount of charge on tape B and the number of electrons lost on tape B are these two numbers. And you can see the results I got from the glow strip code is also the same. Then let's see the experimental setup. So the system is the floating tape, the tape B, and the surroundings are tape A, the gravitational force, and the electric field affecting tape B. And the initial conditions are as follows. The important one is the tape length and tape width. We use it to get the tape area, and the tape mass is this one. And so the assumption we made here, the first one is each tape has the same net charge, and the second one is the charge on each tape is evenly distributed and can be treated as if concentrated at the tape center. And the third one, air resistance and other external forces are negligible. The first step of the experiment is to get the data. So I first prepared two charged tape A and B to measure their interaction. And I measured the initial height of tape B from the surface of the table, which is 0.105 meters. And I used tape A to affect tape B and recorded the height of tape B floating above tape A as 0.138 meters. And I got the magnitude of the distance, the D, is equals to 0.033 meters. And next I did the calculation. So I put the gravitational force on tape B, distance between the tapes, and electric force into Coulomb's law, and to get the amount of charge on tape B, which is this number. Then I used this charge to get the number of electrons lost by tape B. Then I used computational model to simulate the experiment. My glow strip code is as follows, and let's see the result. It's the same as my calculation. So there are some similarities and differences between the two models. For similarities, both uses the same initial conditions like tape mass, length, and distance d, and the calculated charge and number of electrons lost match the experimental results. And about some differences, first one, the model assumes charge is concentrated at the center, while in reality it is unevenly distributed. And the model uses a constant distance d, but observations show d varies along tape's length. Some possible errors are as follows. First one, inaccurate measurement of tape height due to many observations, uneven charge distribution along the tape surface, and external factors like air currents or humidity affecting the tape interaction. And about the two follow-up questions. First one, what if? If electrons have positive charge and protons have negative charge, the behavior of the tapes and other charged objects would remain the same. This is because the force between charges depend only on the magnitude and relative sign of the charges, not on which particle carries the charge. The attraction and repulsion observed would still follow the same patterns. And the second question, my answer is yes. It is important to handle the charged tape as little as possible because contact with your hands or other objects can cause the charge to dissipate or neutralize. This happens because charges transfer to or from the surface of the tape, reducing its net charge and altering its behavior in the experiment. Thank you.